completing the square. We can think of completing the square this way. We have these algebra tiles with, let's say, the length of this is x. And so we can say that the area of this square is x squared. The length here is 1 unit, and this length is also x. That's why you have x times x equals x squared. If this is x and this length here is 1, that means the area of this green rectangle is x. And this other rectangle is congruent to that rectangle. So this has also an area of x. And there is a missing square here to have a complete the square. That is exactly the scenario here in completing the square. There is a missing square here, which is this one. And our task is to find what is this square that's missing so that we can complete the square. And if the numerical coefficient of the squared variable is 1, the length of this missing square is 1/2 of whatever is the coefficient of the x term. And so what is 1/2 of 2? 1/2 of 2 is 1. So this side length here is 1. And since this is a square, this length here is also 1. So what we are looking there for now is this smaller square, which is 1 by 1 or 1 squared. And by doing so, we have just completed the square. And once we completed now the square, you now have this missing square completed. So we now say that we have completed the square. But before we talk about all the details, let's start first with the question, why do we need to complete the square? To answer that, consider this equation. Suppose you have x squared minus 25 equals 0. Find the value of x that satisfies this condition. What we can do is we are going to use the square root property. The square root property says that if x squared equals a, then you can take the square root of both sides and you will get x equals plus or minus the square root of a. So we can use the square root property in order to solve this equation. By adding 25 to both sides of the equality, we will have x squared equals 25. And by applying the square root property, we can take the square root of both sides and we will get x equals plus or minus 5. This means x equals positive 5 or x equals negative 5. When you have cases like this, sometimes you have an extraneous root. So we have to substitute these values back to the equation and check if we have the correct equation. So if x is 5, you have here 5 squared minus 25 equals 0, which is correct. If x equals negative 5, we have negative 5 squared minus 25 equals 0. Negative 5 times negative 5 is positive 25 minus 25 equals 0 is also correct. So in this case, both x equals 5 and x equals negative 5 are solutions to the equation x squared minus 25 equals 0. And we solve this using the square root property. Now, when we have this scenario where you have the quantity x plus 3 squared equals 36, even if you have a binomial raised to the second power, we can still use the same square root property to solve this equation. So what we will have is we get the square root of both sides, and don't forget to put plus or minus sign here, and we'll be able to cancel the exponent. So what we have is x plus 3 equals plus or minus 6, which is the square root of 36. And then solving now for x, we subtract 3 from both sides. So we have x equals negative 3 plus or minus 6, which means x equals negative 3 plus 6, which is positive 3, or x equals negative 3 minus 6, which is negative 9. So we find the solution to this equation by using the square root property. But what if the situation now is like this? We have x squared plus 10x equals 11. We want the left side to be the squared variable, but we cannot just move this 10x to the other side because this has a variable x. What we want to do is gather all the variables to one side of the equation and gather all the constants to the other side of the equation. So at the left side, we have x squared plus 10x. At the right side, we have 11. But our problem is we cannot apply the square root property because this is not a perfect square trinomial. So there is now a need for us to find that missing term to be able to complete the square. That missing term that we are looking now here is equivalent to this square that we need in order to complete the square. And so that's the reason why we need to complete the square, so that we can turn this into a perfect square trinomial, and then later on, we can apply the square root property. So this is now the process in order to do that. Let's say the problem is find the value of c that makes x squared plus 16x plus c a perfect square. There are 4 steps that we are going to follow. We first write this one, x squared plus 16x. That's the first step. Next, we are going to find 1/2 of b. Notice that b is whatever is the coefficient of the x term. So we want that 16. Not the x squared, but the x term. So 1/2 of 16 is 8. So we now write 1/2 of 16, which is equal to 8. This 8 is what we need in the next step. In the third step, you square the result in step 2. What you're going to do is square that 8. 8 squared. And then add this result to these first 2 terms. So the perfect square trinomial now is x squared plus 16x plus this one, 8 squared. And the factored form of this would be, get the square root of this first term, so the square root of x squared is x. Copy this sign. If this is plus, you put plus here. If this is minus, put minus here. And then disregard this, get the square root of 8 squared. The square root of 8 squared is 8. But notice also that the square root of x squared is just the same as getting 1/2 the value of this coefficient. And what is 1/2 of 16? That's 8. So therefore, the value of c to complete the square here is 8 squared. So c equals 8 squared or 64. We're going to use these skills in order to solve our problems involving completing the square. So let's go back now to the problem we were trying to solve a while ago. So to complete the square now here, we'll have x squared plus 10x isolated at the left and the constant isolated at the right side of the equation. And then we are going to complete the square by getting 1/2 of 10. 1/2 of 10 is 5. And you square this 5, that's the term that you are going to add here, 5 squared. If you add 5 squared at the left, you are going to do the same at the right side by applying the addition property of equality. And then once we added that constant, the next step is to factor. We know that the factor of this perfect square trinomial would be a binomial raised to the second power, or a square of a binomial, where the first term would be the square root of this x squared, which is x. The sign is this plus sign. And the second term of the binomial is 1/2 of 10, which is 5. And you can get also that 5 by getting the square root of 5 squared, which is also 5. So this entire trinomial is now factored as the square of the binomial x plus 5. So we have taken care of the left side. We go to the rest of the equation. So equals 11 plus 5 squared. What is 5 squared? 25 plus 11, that's 36. Now this form is familiar with us because we can apply the square root property that we talked about in the previous slides. So we can get the square root of both sides. What we have at the left is x plus 5, and at the right side is plus or minus the square root of 36. What we did was we take the square root of both sides. And then we know what's the square root of plus or minus 36. That is plus or minus 6, because the square root of 36 is 6. Copy the equality sign, copy the x plus 5. And then finally, for our final answer, we have x equals, subtract 5 from both sides, we'll have negative 5 plus or minus 6. And this means x equals negative 5 plus 6, which is 1, or x equals negative 5 minus 6, which is negative 11. So we now say that the roots of x squared plus 10x equals 11 are x equals 1 or x equals negative 11. Now, let's have another example. If we have x squared minus 10x plus 25 equals 27, find the value of x. When you have something like this, check first, what's the middle term? The middle term is 10. What is 1/2 of 10? It's 5. What is 5 squared? It's 25. So the scenario that we have here now is we have a perfect square trinomial. So we don't have to add any number anymore because this is already a perfect square trinomial. All we have to do is factor it. So get the square root of this term, which is x, get 1/2 of this 10, which is 5. Copy the sign. Notice that this 5 can also be taken by getting the square root of 25. So this is a perfect square trinomial. Then applying now the square root property, we have x minus 5 equals plus or minus the square root of 27. Notice that 27 can be written as 9 times 3. And the square root of 9 times the square root of 3 is 3 square root of 3. So we can now rewrite this as x minus 5 equals plus or minus 3 square root of 3. And then solving for x now, we add 5 to both sides of the equality to get 5 plus or minus 3 square root of 3. So this is now our solution. There are two roots. One is 5 plus 3 square root of 3, and the other one is 5 minus 3 square root of 3. Okay, let's have another example. Now, this time, we have a coefficient other than 1 in the x squared term. So we still follow the same procedure. You copy the 2x squared minus 7x and isolate the constant at the other side by subtracting 5. And then, before you get 1/2 of the middle term, we are going to divide each term first by 2. So that we can cancel this out. We are left with x squared minus 7x over 2 equals negative 5 halves. And then our b now is this part. We need to get 1/2 of 7 halves. So what is 1/2 times 7 halves? That is equal to 7 over 4. That 7 over 4 is what we need to add here. 7 over 4 squared. Since we add 7 over 4 squared at the left, we are going to do the same thing at the right side. So we add 7 over 4 squared. Now the next step is to factor this perfect square trinomial into a square of a binomial. And we know that the first term is the square root of x squared, so we have x. The sign is this minus, and the other one is the square root of 7 over 4 squared, which is 7 over 4. And then at the right side, we have negative 5 over 2 plus 7 squared is 49 over 16. And then let's compute this part. We have negative 5 over 2 plus 49 over 16. The least common denominator is 16, so 16 divided by 2 is 8 times negative 5 is negative 40. 16 divided by 16 is 1 times 49 is 49. So we got 9 over 16. So this part is 9 over 16. What we have now is x minus 7 over 4 squared equals 9 over 16. Now let's continue our computation here. Get the square root of both sides, so we have x minus 7 over 4 equals plus or minus the square root of 9 is 3, the square root of 16 is 4. So finally, our answer would be x equals positive 7 over 4 plus or minus 3 over 4. And simplifying this, we have, if you take the plus sign, you have 7 plus 3 is 10 over 4. Or, if you take the minus sign, 7 minus 4 is 4 over 4, or 1. So our roots are x equals 5 over 2. The lowest term of 10 over 4 is 5 halves, and x equals 1. So these are our two roots for this equation. Now let's solve another one. Suppose you have x squared minus 8x plus 22 equals 0, solved by completing the square. So the first thing we have to do is isolate all those terms with variables at the left side and all the constants at the right side. And then complete the square. We get 1/2 of 8. What is 1/2 of 8? It's 4. And then you square it to get 4 squared, and then add 4 squared here also. And then this is now a perfect square trinomial. So let's factor this into a square of a binomial. We have x for the first term, copy the minus sign, get the square root of 4 squared, so we have 4 equals 22 plus 16. Next, we have x squared minus 8x plus 22 equals 0, solved by completing the square. The first thing to do is isolate these terms with variables at the left side. So we got x squared minus 8x, and this constant we put at the right side, so equals negative 22. We subtract 22 from both sides of the equation. And then after this, we are going to complete the square. We are going to complete the square. The term that we need to complete the square here is 1/2 of this middle term because the coefficient here is 1. And 1/2 of 8 is 4, and then we square that. So we add 4 squared. And we add also 4 squared. And then we know this is a perfect square trinomial. The first term of the binomial term inside the parenthesis would be the square root of x squared. So you have x, copy the minus sign, get the square root of 4 squared to get 4, equals negative 22 plus 16, which is equal to negative 6. And then apply the square root property. We take the square root of both sides to get x minus 4 equals plus or minus the square root of negative 6. Notice that you have now here the square root of a negative number, which is an imaginary number. So we can rewrite this as x minus 4 equals plus or minus the square root of negative 1 times 6, which we can rewrite further as x minus 4 equals plus or minus the square root of negative 1 times the square root of 6. But the square root of negative 1 is the imaginary number I, so we can write this as x minus 4 equals plus or minus I times the square root of 6, where I is equal to the square root of negative 1, which is this one. Then finally, solving for x, we add 4 to both sides of the equality to get x equals 4 plus or minus I times the square root of 6. Let's suppose we are given these two scenarios. One is solved by Tunette and another one is solved by Ralph. Where is the error? Tunette got this answer and Ralph got this answer. So who is correct? What's the main difference? First step, they're the same. Second step, they're the same, so no problem. In the third step, you have here plus 16. You also have here plus 16. And then at the right side, there is a plus 16 here, but that is missing in Ralph's answer. Now, that's an error on the part of Ralph, because when you add a value at the left side of the equality, you should add the same value at the right side of the equality, applying the addition property of equality. If you forget to add 16 to the other side, your resulting answer would be wrong. So in this case, don't forget to apply the addition property of equality when you complete the square at the left side of the equality. Okay, I'm just using this to remind you of the common mistakes many students are committing. Okay, for our exercises, I'm going to show you a question. You can pause the video and try to answer it. And then in the next slide, I'm going to show you the answer. So solve its equation by completing the square. You have 4a squared minus 8a minus 38 equals 2. What are the roots? Okay, pause the video. Now, assuming that you already answered the problem, let's check your answer. The answer should be a equals 1 plus or minus the square root of 11. So how did we do that? First, we isolate all the terms with variable a at the left side and all the constants at the right side by adding 38. So 38 plus 2 equals 40. And then since the numerical coefficient here is not 1, we divide each term by 4. So you get 4a squared divided by 4 is a squared. Negative 8a divided by 4 is negative 2a. 40 divided by 4 is 10. And then we get 1/2 of the middle term, 1/2 of 2 raised to the second power. So 1/2 of 2 raised to the second power to complete the square, and do the same thing at the right side. But this 1/2 of 2 is simply 1, and 1 squared is 1. So this is just the same as a minus 1 raised to the second power, where this a is the square root of a squared. This is 1 squared. The square root of 1 squared is this 1. And then that becomes a square of a binomial. This is 1, so 10 plus 1 is 11. And then add 1 to both sides of the equation. So you get a equals 1 plus or minus the square root of 11. Okay, here's the next question. Solve this equation by completing the square. 4a squared plus 16a plus 82 equals negative 10. Pause the video and solve the problem. Now, assuming that you have completed your answer already, here's the answer. So again, we isolate all the terms with variables a at the left and all the constants at the right side. And then there's a numerical coefficient of 4 here in the a squared term. So we divide each term by 4. Divide this by 4, you get this. Divide this by 4, you get this. Divide this number by 4, you get this one. And then we are now ready to complete the square. Get 1/2 of 4 is 2, and then square it. Do the same thing at the right side. Then factor this into the quantity a plus 2 squared. Simplify this, you get negative 19. And then apply the square root property, you get this next step. Now, since you have a square root of a negative number, we can write that as the square root of negative 1 times the square root of that positive number. And then the square root of negative 1 is the imaginary number I, and then we subtract 2 from both sides to get this final answer. 6r squared plus 12r minus 67 equals negative 3. You can pause the video and solve this problem. Now, let's go to the answer. So the first thing to do is add 67 so we can isolate the terms with variables and the term that are constants. And then there's a number 6 next to the squared term, so we divide each term by 6. You get this next step. We are ready to complete the square. 1/2 of 2 is 1 raised to the second power, so you have this 1 squared. Do the same thing at the other side. Then factor this out, get the square root of this, get the square root of the last term, you have this binomial. And then simplify this. And then apply the square root property. The square root of the quantity r plus 1 squared is r plus 1. The square root of 35 over 3 is plus or minus the square root of 35 over 3. But there is a radical in the denominator, so we rationalize by multiplying by the conjugate of the square root of 3. So we multiply by the square root of 3 over the square root of 3. Square root of 3 times square root of 3 becomes 3. And then 35 times 3 is 105, so you get the square root of 105. All the rest are copied. And then we subtract 1 from both sides of the equality. And combining these two, the least common denominator is 3. So 3 divided by 1 here is 3 times negative 1 is this negative 3. 3 times 3 is 1 times the square root of 105 is square root of 105. So this becomes our final answer. Now, 2 more problems. Solve each equation by completing the square. So pause the video and solve this. For our answer, here is the answer. Solve each equation by completing the square. You have 4r squared plus 16r minus 40 equals 8. Pause the video and solve the problem. Now for our final answer, so we have the same explanation as the previous problems.